In this video, we will demonstrate the process of setting pin types or overriding pin types when creating symbols for parts using PartBuilder. The SmartFrac feature, which creates the initial symbol description language file, does a much better job when the actual pin types are properly defined. SmartFrac initially places input pins on the left, output pins on the right in the All Pins symbol. All other pin types beside power and no connect pins are initially set to choose side, so that the user can place them on the side they like. It puts the power pins and no connect pins in their own symbol with a much less restrictive pin match. While we might want to override a pin type for any of the PartBuilder input flows, there are several pin info types in PartBuilder where the pin type may not be provided, or the pin type is wrong for the user application. Some specific cases are the simple BGA, BSDL file, IBIS file, and the generic CSV file types. In this video, we will be setting pin types for pins read from a TI IBIS file for a DAC. In this file, only the digital pins were really assigned pin types, so it's our job to fix the rest of the pins. Pin types can be set and defined after reading the input pin report file, without having to touch the files we got from the vendor. PartBuilder uses the pin type override file setting to store a pointer to a file that contains pin match strings and the type that should be assigned to any pin that matches that string. If the pin type override file exists, PartBuilder will read it and use the rules in that file to assign and/or override pin types. After all the pin types are assigned from the override file, PartBuilder will use the match string specified in the Auto Power Match Names config setting to set any unassigned pins to power type if they match any of the strings in that config setting. While the pin type override file may be created in a text editor, the Pin Explorer pop-up GUI allows us an easy way to interactively create the pin override file. In release 18.5.1, the default pin type override file name has been set to pin_type override.txt. This file may or may not exist, and it will be created when we use the functions in the Pin Explorer menu to save the assigned pin types. Here we can see the Device Pin Explorer open. The Device Pin Explorer has a bunch of filters. We can use a pin name match, a pin type match, a pin number match, and a symbol match. We won't be using the pin number or symbol here. We're going to play with the pin type match and the pin name match. If I turn on this check button enables each of the filters. So right now pin match is set to nothing, so it found 72 pins. It basically selects all the pins. It found 72 pins matching that. If I turn on the NC pin types, then it's going to filter it, and now we only found 46 pins matching the enabled filters. So these are all the pins that didn't get assigned in the IBIS file. So what our job is to assign those. So what's going to happen is we're going to use some pin matches, and we're going to define what these are. So let's search for anything _in. And we can see we have 12 pins here that match that. So why don't we set those to input? So when we have the pin name match in, we can use this choose pin type, and we can assign those to input, and we say assign type to matching pins. So what this is going to do is assign the input to anything that matches this _in. And then I'm going to say save type assignments, and it'll write it to pin type override.txt. And if we go look at that, what it did is it added _in equals input and plus a comment saying pins matching in will be assigned to pin type input. Let's move this over so we can see both of these happen. Let's look for out now. And there is no pins named out. So let's go back to look at all the NC pins again. We have these LP pins. Let's make those inputs. So another way we can do this is we can select those pins, LP. We can right click and say assign pin type input. And then we'll save those type assignments. And then we'll refresh this. And we can see when we do that, it does a more specific match, saying LN equals A, LP equals input, LPC is input, and LPD is input. and we still have the underscore in equals input here. It moved it around, but we have it. So pins matching underscore in will be assigned type pin input, and then these are the individual maps. So now we're down to 26 pins that match NC, and if we turn off the NC, again we have 72 pins. So we can use this. Sometimes the pins will be unassigned, but in this case they were all mapped to no connect in that IBIS model. So now we're going to say the heart in B. Let's find the HART, and those are inputs as well. And we'll hit enter, and that's 4 of them. So in this case we're going to match anything with heart to input. So we're going to use more of a match. Instead of an exact one like this, we're going to use the heart equals input. So we'll click that one, we'll save the assignments, we'll revert the file, and now we should have a heart equals input in here. Okay, and so that's the job we have to finish up mapping all these pins. So once again we're going to turn off there, and now we have 22 pins match. So here's our V out, I out, V out, I out, V out. So let's look for any pin containing out, and we'll assign it to an output. We'll assign that, we'll save the type assignments, we'll revert this buffer, and now we say out equals output. So any pin that contains out will be assigned output. The LNA pin will be assigned an input, the LPB pin will be assigned an input, and then let's turn off this filter again. So now we're down to 13. The vSense pins are inputs, so we can make those, and we can use control click here so that we can do that, and we'll right click and assign pin type input. Again, we'll save the pin type assignments, relook at the file, and we can see that the vSense pins are added here. So now let's assign all these guys as inputs. So we can also just drag, and we'll assign pin type to input. We'll save those pin types, and now we have all the pins assigned. If we look, we have all the pins. If we assign no connect, no pins show up. So that's the job of assigning pin types to a pin type override file. And again, we want to do that before SmartFrac runs so that we get the best possible input structure to the SmartFrac, so it can place the pins on the right side of the part. So I'm going to close that and close that. Once we have created our pin type override file, we want to reread the pin report to give SmartFrac a chance to rebuild the initial STL template file before we start editing the template using the STL editor. Then SmartFrac will do a much better job creating an STL file that makes sense for us. In this case, SmartFrac will now detect differential pairs for the vSense pins because they are no longer treated as no-connect pins. Thanks for watching this video demonstration. Your thoughtful comments are always welcome. Please visit us at www.cadenhance.com to download the tools and request a free demo license to start working with PartBuilder.